That's actually a reference to something in the UK. Last week we had Pancake Day, also called Shrove Tuesday. So over here on that one day of the year, everyone eats loads of pancakes. But the talk is about what's inside the Civo stack. So before we go on to what our new platform is, I just wanted to take a minute to describe what our old platform was and be able to then say, this is what's different about the new platform and this is why we think it's better. So to start off with, the hardware for the old platform was based primarily around Dell servers, such as this R640 on the right-hand side. And when we bought this hardware, we were super pleased with it. It was high performance. We were using Intel Xeon Gold CPUs, and the whole platform performed amazingly well. The problem then came from the fact that the underlying platform was using OpenStack. We started off on Mitaka, and we upgraded it over the years through a few versions to OpenStack Queens. All sounds good. So what went wrong with it? For anyone that's used OpenStack, you will probably be aware of their problems with the API. The API is inconsistent in different places, and there are times when you'll send an API request and you'll get a response back to say, yes, we'll create that instance, we'll reconfigure that firewall, and then you'll make the next API call and it will have forgotten the fact that you asked for it in the first place. Now, they use RabbitMQ as a core component as kind of a central messaging bus. Not sure whether it's just a bad architecture or maybe RabbitMQ was overloaded and it was dropping messages, but this becomes a real problem for us that we can't rely on the API to behave consistently. So we ended up with what I'd call a split brain situation. We couldn't rely on the OpenStack API, so we had to build our own API layer that acted as a cache and a translator and also kind of a supervisor role for the OpenStack APIs to make sure things actually happened the way they were supposed to happen. The next problem we had with OpenStack was we had a cluster nicely running OpenStack Queens on, I think it was Ubuntu 16.04, and we want to upgrade to the next version, stay on top of bug fixes, security fixes, etc. Unfortunately, the next release of OpenStack required the next version of Ubuntu, and you can't upgrade either the version of Ubuntu on Queens or upgrade to the next version of OpenStack and then Ubuntu. You had to do both at the same time. Now, the best advice we got out of the OpenStack operators mailing list was, it's simple. You create a brand new cluster running OpenStack Rocky, and then you migrate all of your customers over one by one. Now, obviously, we're a small company, so it didn't work for us to completely duplicate our infrastructure just for a migration. And the final problem we had was that the speed of OpenStack from cluster launches was rapidly decreasing. Now, again, this may come down to RabbitMQ being overloaded or various bottlenecks in the platform and single points of failure. But it was certainly causing us problems in terms of where we wanted to be with our platform. So we built something entirely new. Now, the new networking infrastructure for our Civo stack looks something like this. We actually have at least 3 connections to the internet, but basically every component in the networking stack is both duplicated and connected to each other. So we could lose one of each of the edge routers, one of the spine switches, one of the top of rack switches, and everything would continue as normal. Obviously, on a cluster level, we have a bunch of compute servers. So if any one of those goes down, the others can pick up the workload. So we have a resilient software stack now. The hardware for it, we've chosen to use the Open Compute project. Now, this is an amazing technology where they reduce duplication in things like the power supplies, so there's not power supplies per server, and they achieve amazing density by using 3 compute servers in each 2U rack. For our storage platform, all of these servers are actually running NVMe drives, so we've got one of the fastest storage platforms for hardware now in any hosting provider. On the software level for Civo Stack, we've of course gone with Kubernetes because we're a Kubernetes company. And as the guru of Kubernetes says, Kubernetes is a platform for building platforms. So we don't just use Kubernetes as a regular end user would, we've built our own extensions and we run them with Kubernetes being the underpinnings of our entire operation now. We've partnered with Storage OS to provide that fast storage framework for us. And we're in the middle of writing a driver so that in customer K3S clusters, we'll be able to write down to storage OS without having to use things like Longhorn or local path provisioners in the K3s clusters. But the real special sauce for how we do things is we have a whole bunch of Kubernetes operators. So for those of you not familiar with Kubernetes operators, the principle is this. The etcd database that Kubernetes uses is the central source of truth. Everything is stored in there. And then whenever we change a custom resource, so let's say we have a custom resource called a K3s cluster. Whenever we make a change in the etcd database for a customer's K3s cluster, Kubernetes will call the operator, which is running our custom code, and say, the user has requested it scale from 3 nodes to 4 nodes, or from version 119 to 120. We make one simple change, we update any external resources required, and then we save those results back into the database. Now, regardless of whether we consider that job finished or not, if the etcd database state doesn't match the actual state of the system, it will call reconcile again, and it will keep looping until the desired state matches the actual state of the world. So this gives us a nice clean architecture we can use to develop custom components. And the final piece of the puzzle is, how do we get Civo Stack installed? So we have entire racks full of open compute hardware shipped out to data centers. And the process is basically this. The data center receives the hardware, they plug it into power and networking, and then we connect into the out-of-band devices and configure those. Then the out-of-band device will reboot all of the servers and install the base operating system on every server via PXE booting. This process takes about 15 minutes. Once that completes, we run an Ansible playbook, which installs Kubernetes and a single custom operator called our Civo Stack operator. Again, that takes about 10 minutes. And finally, the Civo Stack operator installs storage OS and all the rest of our custom operators to form the pattern. So as you can see, inside of about 45 minutes, we can go from an empty rack of hardware through to a fully configured Civo Stack region. So the advantages the Civo Stack brings us over the previous situation we had is the Kubernetes operator principle is easy to maintain. We don't have a split bane anymore because the Civo API communicates directly with the Kubernetes API and doesn't store anything locally. So our Kubernetes superclusters are the central source of truth. And finally, we almost have zero touch provisioning from a new cluster arriving and being ready to actually use by customers. And in the late great Steve Jobs fashion, there's one more thing. While we were building Civo Stack, we managed to give the UI a complete refresh and implement dark mode for those of you that are into that sort of thing. I'm sure a lot of the community will be aware I'm personally not a fan of dark mode, but I'm happy that you guys have it. So that's the end of what Civo Stack is and how it works.